Hello everyone, today we have problem boards to save people. Thank you first of all for your awesome comments. Now let's move on to this question. So in this question we are given an array people and the people of I is a weight of the person. Okay, so we are given an array with weights of person and we have infinite number of boards which is redundant, and each board can carry a maximum weight of limit. Okay, and one thing also that each node carries at most two people, no matter what's the capacity. If it's full or not, it will carry two people at the same time. And obviously the weight of two people should not exceed the limit. So what we have to find is the minimum number of boards to carry given person. Okay, so let's say we have an array 1, 2, 3 and 2 again. So what we can do is, if the limit is 3, if limit is 3, then this person cannot be paired with any other person. He will require board for himself only. Okay, because its size is equal to the limit. So what we will have to do is, we will have to allot one board only for this person. And if you look at 1 and 2, the sum of weight is 3 and the limit is also 3. So we can allot one board for both of them. Okay, for both of them this will be board, and then for this 2, his weight is less than 3, but we have no more 1. Okay, we have no more people to pair with, so we'll have to give him one board. So we'll have to send 3 boards. Okay, so that's how we roll in this question. So how are we going to solve it? We are going to solve it using the 2-pointer approach as in the last question. So now let's take another example. So if we are given an array, let's say 1, 3, 2, 4, 5, 3, 4, and what we are given the limit is, let's say our limit is 5. Okay, our limit is 5 only. So what you can do is, you can send one board to this 5, then you can pair this 4 and 1 board for them. Then one board can be given to these two, 3 and 2, and then 3 and 4 cannot make a pair. So what we have to do is, we'll have to send one board for both of them. Okay, so one board will be sent to both of them. So now what are the minimum number of boards that we required? Those are 5. So how did we solve it? How did we solve it? Is by looking at the maximum person and then choosing which person can fit with him. Okay, so what we can do is, we can sort this array. So first let's see how will the sorted array look like. So the sorted array will be like 1, 2, 3, 3, 4, 4 and 5. Okay, now the people with larger weight are on this side and people with smaller weight are on this side. So what we are going to do here is, we will place 2 pointers, I and j. I will be here and j will be here. Okay, so if you look at j is on the larger side, so if let's say our capacity here was 5, okay, capacity was 5. So what we will do is, we will, for this j, we can see if we can fit the smaller element within the boat or not. If j is 5, so we cannot fit 1 with it, because now then the weight will become 1 plus 5, that would be 6, and it is greater than capacity, so it won't fit in the boat. So we will allot one boat to this 5 and move this j to left. Okay, and now here we have now 4, and for 4 we will check if we have a smaller element. Okay, a smallest element which we can fit with 4. Okay, so we are placing this I pointer to just get the smallest element possible. Okay, so for j, also one thing to note here is that j is on the rightmost element, so our j is on the max weight left, and I is on the minimum weight that is left to be sent on boat. Okay, so that is not who is not allotted boat yet. So for 4, if the minimum weight is 1 and we can fit 1, then we will do that. But let's say our minimum weight was 2. If our minimum weight was 2, then we cannot fit 4 with 2, and in that case we don't need to check for more elements. We don't need to check to other elements of array, because I gives us the smallest element that is not allotted a boat yet. Okay, so that's why we don't do that, and we will just for this I for this j we will check if we can fit I or not. Okay, so it was 1, so we can do that. So our capacity now would be 4 plus 1, that would be 5, which is less than equal to our limit. Okay, so we can send one boat, we can fit both of these people in one boat. Okay, so let's say we gave b1 to this one and b2 to these elements. Okay, and now if this happens, then we will have to move j here, and I will also move front now because this person is allotted boat. And now for this j, we have I equal to 2 and we cannot fit it. So what we will do is we will send one boat b3 only for this j. Okay, we won't move I forward because it is possible that this I may fit with some other boat. Okay, with some other boat. We will see that in the next iteration when we will move j to here. Now our j is pointing to this 3 and our I was left at 2 and it is at 2 because it couldn't fit. Now 3 plus 2 is less than equal to our limit. That's limit, not capacity. That's so what we will do is we will send them a single boat, so both of them will given b4 and b4. And now when I is equal to j, okay, I and both are now I and j both are now at 3. What we will do is we will send a boat for 3 also. We'll have to send a boat for this single person only, so we'll send a boat b5. So we are getting b5. That was the answer that we got. Okay, so we can see that it is working now. Okay, this was case when we had one element left and I was equal to j. We can also have a case where we don't have this 3, so that would be 3, 3, 4, 4 and 5. Okay, so in this case what would happen is when I and j would come here, then we will send a boat for both of them, and now our j and I will cross each other. Okay, so what we are seeing here is that in the while loop we will have the condition while our I is less than equal to j, because in less than equal to we will have to send one boat. Okay, and if we do that, if when I is equal to j, what we have to make sure is that we will add one boat to this I and j both, and both are at the same position, so we don't need to count anything. But the thing is that this is 3, so what we will check is we will check the people of I plus people of j, and this sum would be now 3 plus 3 because we will consider this element twice. 3 plus 3, that would be 6. So it will say that no, you need to send one boat for this j only and I will remain there. Okay, and then j would proceed again. So yeah, that would work. That won't make a difference. But if you want, you can make a if condition in loop that if our I is equal to j, then just add 1 to boat count plus plus and break from the loop. Okay, so let's move on to the pseudocode of this problem. Okay, so what function we are given in this question is num rescue board. So the function is int num rescue boards. So it has two arguments, the people vector or list in Java and limit. Okay, so what we'll need is two pointers. So first int I is equals to 0 and our j will be at people dot size -1 at the last index, and we will need a variable boat count. So int boat count, and what the first step we did for this two pointer approach to work, that is to sort the people array. Okay, so we will sort people dot begin and people dot end. People dot end. Now we have sorted it, so it's just about a while loop to solve this using two pointer. So we'll make a while loop while our I is less than equal to j. Okay, so while I is less than equal to j, what we will do is we will check if our people of I plus people of j, that is nothing but in the array I is at here and j is here, so we are checking that if this and this is less than the limit, this plus this is less than limit, then what we have to do is we will increment I, we will do I plus plus. Okay, and if that's not the case, so what we should do is, if that, okay, we have not only to check if it is less than limit but also less than equal to limit. Okay, it can be equal to limit, the weights of the people can be equal to limit. Okay, so then we will do I plus plus, and if it's not, or even if this condition fails, if this condition is not true, what we have to do is we have to move only j ahead. And even if this condition is true, if this condition is true also, then also we will have to make j to a left side as we allot both boards to both of them. So we can write it after the if block, we will write j minus minus, and for j you allot a board. Okay, and if this condition was true, then you moved I here and j here and you allotted a single board to them. Okay, so what does this mean? That in each iteration you are allotting one board. Okay, the only difference is that if the weights of people fit with in the limit, then you are also allotting a board to I, so you're just incrementing the I in this condition. Okay, so now we will just outside this if condition, we will have board count plus plus, we will increase it, and yeah, that's about the code. And then at the end we will just return our board count, we'll return our board count. If you haven't understood this I less than equal to j, why it would work without the if condition, then let's do it with the if condition also. You can remove this if condition also, because if I is equal to j, okay, and even if that we had limit of 5 and this was 3, we were consider it twice. So what would happen is that I and j both will be here, I and j both will be here, but as you allot one board to j, okay, so I'm talking about the logic of this code only, because you will consider this 3 twice. Without this if condition you will consider this twice, so that would become 6. That this condition won't be true, so your I will remain there only, this won't run. Okay, but this j minus minus will run, as you will allot one board to the jth element only. So now your j will be decremented and your I will remain here. So in the next iteration what you would have is that your I, this condition would be false and you would break the loop. Okay, so it would work, and if you want you can try it with and without this if condition, that you can also have an if condition. If I is equal to j, then what we can do is just increase the board count once, board count plus plus, this increase this once, and then break the loop, because now both of them are at same position, then you can break the loop. Okay, so yeah, that's the code of this problem. I hope that you have understood this problem. I don't know why the LeetCode links are not working. I will look into it. Right now I will give you a GitHub link which you can see if you want to see the code which I have written for this problem. Okay, so thank you, bye bye.